Miller. What I'm going to do here is take you on a quick tour of the BME BlowerDyno. First thing I want to show you is how we get the measurement for cubic feet per minute, the airflow actually going into the supercharger. If you'll notice, right up at the top, there's 4 CFM fans. They come from Superflow. They measure cubic feet per minute. All of the air that goes into the supercharger goes through all 4 of those fans. Now we're going to walk into the dyno room and I'm going to show you how it goes into the supercharger. Alright, now we're in the dyno cell itself, and what I want you to see is we showed you the fans and how all the air for the blower comes in through those 4 fans. Now I'm going to show you what happens when it comes through the fans. If you look up here, you'll see that there's a plenum where all 4 fans collect. They go into a 24-inch steel pipe. The 24-inch steel pipe then comes down into this flexible hose, and as it comes down into the flexible hose, it goes into the very top of the Gibson Miller injector and then goes into the supercharger. So we can measure all of the airflow, because basically a blower is an air pump that goes through the supercharger. Okay? Now, we're going to continue on. I'm going to show you the dyno a little bit, and then we'll show you the control console. Okay, I showed you the airflow getting into the supercharger. Now I'm going to show you how the dyno actually operates. The dynamometer is basically a big water brake. Now what's interesting about this one is this water brake, or this water wheel, was built back in the 40s in World War II for testing radial aircraft engines. As a result, it'll hold probably 6,500 foot-pounds of torque. Now, the problem with it is that it's so large and it's capable of holding so much power, we can't run that wheel, that water wheel, over about 2,500 RPM. So we have to reduce the RPM of the engine down so that the water brake can operate within its RPM limits. How we do that is we come over here and we have a planetary box on this thing that reduces the input from the engine to 1/4. In other words, it's a 4-to-1 planetary box. So if we have 8,000 RPM coming in, it's got 2,000 RPM going out. That's how we maintain control of that wheel so that it's not spinning at the same speed that the engine is. And obviously, this is the blown alcohol engine. It's exactly like what we have in our own race car. This thing generates about 2,000 horsepower at about 7,500 RPM. Runs on methanol only, and even though this is an engine dynamometer, we only use it for basically checking the cubic feet per minute of airflow in the supercharger. Although we can check horsepower and EGTs and manifold distribution, blower pressure, etc., etc. One of the things that we check on the blower is we check the rear gear pressure to see how the seals are doing. We check the front gear case pressure to see how the seals are doing. We check the snout pressure to see how the snout is doing as far as overpressurizing. We also monitor the temperature in the plenum. We also monitor the pressure in the plenum. So we can monitor anything we want on this supercharger to find out exactly what this thing is doing at any RPM level that we want. And the way we run this thing is we basically fill the wheel up to about halfway, start the engine up, let it warm up for about 1.5 minutes, and then once it's finished warming up, then we give it full throttle, and within 2 seconds we then start dumping water. And the water dump is right down here. And the water dump basically dumps water out of the wheel and goes into the sewer system, but because it's just water, it doesn't contaminate anything, because we are a very green company, I think. So by dumping the water, it allows the engine to accelerate up to approximately 8,500 RPM from a flash of about 6,500 RPM. The blower always runs at 50% overdrive, so we can monitor blower speeds all the way up to 12,500 RPM if we want. One thing that needs to be mentioned here is that this dynamometer originally was constructed merely to test blown alcohol engines by Dale Armstrong when he was the crew chief on Kenny Bernstein's Budweiser King top fuel car probably 15 years ago. And we managed to acquire it about 4 years ago and have basically updated it and redone quite a few things, because the unit sat for over 10 years in Kenny's shop down in Lake Forest. So we're fortunate to know Kenny and Dale, because this helps us develop a much better supercharger. What you see behind us is a muffler that's about 4 foot in diameter and about 20 foot tall. Goes out through the roof. We obviously don't want to be too noisy here. The engine does generate 2,000 horse, and even though we're in an industrial area way out next to the airport in Carson City, we still want to be good neighbors. And so you can actually stand outside the building when this thing's running at full throttle and it just sounds like a hot streetcar coming down the street. Over here in the corner is a water tower. The top tower is for cooling. The second tower on the bottom is actually the reservoir for water. We really don't need to cool the water because we're just using it one time. It goes from that water tank there into the dyno wheel, gets recirculated, and then we just dump it out and then we refill it. So basically, even though we could run engines on this dyno on an hour-by-hour basis, because it's basically only used for the supercharger, we use very little water, and as a result, the engine and the dyno wheel itself doesn't get very hot. So now we're going to go in the dyno console, and I'll show you the run that you have just witnessed. So what I'm going to show you now is the dyno console, which obviously if we run this thing, we need to record data. The data recorders that we use are twofold. One is a DPAC dyno system data. The other one is a racepack data acquisition system. The racepack we use primarily in case there's something that happens to the DPAC system, so we have a backup, or vice versa. If something happens to the racepack, we have the DPAC for backup. So it's a double redundant system, or redundant system. If you look at the screen, you can see that the flashing line here is the run that you just witnessed. The other line here is a master blower that we've managed to produce about 4 months ago, and we use that as a standard, if you will, to see if we're progressing or going behind, because the blowers are very, very sensitive to inlet shapes and lengths and well, as we all know, the curvature of the inlet, because it is a pump, and getting air into the thing is the hardest part. It'll get out if you can get it in. The bottom line here is a competitor's blower that we ran about probably 3 months ago. And the difference between these lines here at this juncture is about 6.5%, and down in here it's about 4%. And percentages are very, very, very difficult to gain. If you can gain 1%, you're really doing a really good job. The race pack shows us how the engine actually ran. This is the RPM of the engine flashing up to 6,500. We then let it go at a 2-second time frame. It starts to accelerate because remember I said we're dumping water out of the wheel. We take it up to 8,500. This is the CFM, or cubic feet of air per minute, going all the way up to 8,500 RPM, and you can see this is the boost. The boost stays very flat all the way on up, and that's a result of the blower being very efficient at high RPMs. A lot of blowers tend to dive. As you can see here, that line right there, instead of continuing up, it just basically flattened out, and that pretty much is all inlet. Okay, now to finish off, I'm going to show you just kind of quickly how we do this. First of all, we turn the power on, hit the planetary pump, which puts oil into the planetary gearbox. It has a pressure feed into the planetary gearbox to keep all the gears happy. We then turn the 2 pumps on for the water tower that circulates the water through the dynamometer, allows us to charge the wheel. And the exhaust stack here allows us to open up 2 valves that are on top of those mufflers, because it snows here in Carson City, so we have 2 valves sitting on top of those mufflers that are air actuated to open up to allow the exhaust out. The other one is the intake shutter, which was there at the beginning where I showed you the cubic feet of air per minute fans. The shutter opens and closes so that it doesn't get contaminated. You can see we have a green board here, which, me being an old submarine sailor, green board means it's safe to take the submarine down. So we have that over here on this side. We have a load and unload, which adds or subtracts water out of the wheel. We have the altimeter. You can see here in Carson City we're about 4,600 feet. And of course this is a start button, which actuates the air motor that starts this thing. It's got a very, very large air operated motor that cranks the thing over to start it. And when we run it, we just basically give it wide open throttle, hold it there, and then when the engine reaches 8,500, just shut it back off again, and then record all of our data. So hopefully that explains a little bit about how we run the blower dyno, and I think you'll see that this is probably the only blower dyno of its kind in the entire world. So if you have any questions, feel free to give us a holler on the website or at BME.